Just a disclaimer that I got an email yesterday morning from Pierre saying, "Hi, I'm on my way to Oslo and we're doing this mini-PasswordsCon. Are you still up for talking?" And I was on a date last evening, so I threw together some slides after that. So it's a bit rough around the edges. It's quite short. I'm going to talk about a very, very specific topic called DPoP, which does not stand for Danish pop music, but it's
Deutsch.
Yeah, it's Deutsche pop, exactly. That's for people who've been in the OAuth game for a bit. That's actually a joke, because when they were working on that specification, this ad for Deutsche Pop kept coming up. So anyway, I'm Håkon. I work in a company called Udelt, where I'm a consultant. I build identity and access management solutions for our customers. Right now, I'm with a customer in Oslo called Aiden. They are a very exciting healthcare startup, or they're not really a startup. They don't have any paying customers yet, but they have grew from 3 people to 100 people in 3 years. So I did just won their first tender. I teach software security part-time at the University of Agder, and I pretend to be a dog on the internet. So what I do, I work a lot with OAuth-related topics, which is also what I'm going to talk about. And I guess everyone has heard about OAuth, but we can do a short recap. Very, very, very simple recap. We have a client who wants to communicate with an API. There we have our resource server, or the API if you want to, and that's protected by using OAuth, so it requires an access token for you to call it. And then we also have an authorization server. What happens is we first do a token request from the client. In this case, there is no user involved. We are keeping it simple. This is the most basic, it's machine-to-machine communication. The client authenticates itself towards the authorization server, which then verifies that the client is allowed to access the resources it wants to, and it returns a token response containing this token, as you can see. And then we use that token to do an API call to the resource server. The resource server validates that access token, and it returns an API response. Let's dig a little bit more into the token request. So as we only focus on machine-to-machine here, there's no authorization step for the user. The user doesn't have to authenticate or anything because there's no user involved. But the client still needs to authenticate it itself, and it does that by using a client ID and a client assertion. So for those of you that have been working with OAuth before, do notice that I refuse to talk about client secrets or shared secrets. And that is verified by the authorization server. So the authorization server verifies that assertion by using the client's public key that it already knows because the client is pre-registered. And back we get a token response that looks like this. So we have an access token. We tell the client what type of token it is and when it expires in seconds. So let's take a little look at that actual token. And here we use it to call the resource server or the API if you want to. And we put it in the authorization header, and we tell the API that this is a bearer token. A lot of people don't really know what that means. They just know that I can use this token to do a request to this API. So to quote the specification, a bearer token is a security token with a property that any party in possession of the token, also known as a bearer, can use the token in any way that any other party in possession of it can. So in other terms, as long as you have that token, you can do calls with it, no matter who the token was issued to.
Scary stuff.
It's very scary, right? And this is also usually where a lot of people get surprised when I tell them this, because a lot of people don't really understand the features of the token. They just know that I can use this to call the API. This is also by design because they wanted to keep it simple. The OAuth specification, the OAuth 2.0 specification was all about simplifying what we had in the OAuth 1 specification. It's not like we ever leak tokens to user space, right? Or in logs, or that we can't guarantee that communication is safe, right? We can always do that. No, of course not, because we don't live in a perfect world. But in a lot of cases, that's okay. We know about the risk, or a lot of developers don't know about the risk, but it's okay. But then you also have a lot of applications where it's not okay. For example, where I work in healthcare, imagine a token getting leaked that allowed someone to prescribe medicine. So what we do want instead of a bearer token is a proof of possession token, which means a token that is bound to the client that requested it. In other words, it's only the client that requested it that can use it, because you want to prove that you are the one who's in possession of that token. Funny thing is that we had those in OAuth 1, but when they worked with the OAuth 2 specification, they decided to remove it because they wanted to simplify the framework. And that whole decision there, that's a long story by itself that I won't go into. There are a few funny YouTube videos on it if you want to watch those. But that ultimately led to us having two different RFCs. So there's the one that specifies the authorization framework and how to obtain a token. And then there is one that specifies the token type and the usage of said token. What this did was that this made room for us to come up with other types of token in the near future. The specification came out in 2012. Demonstrating proof of possession, or DPoP, came out in 2023, so it took some time. But in between that, suddenly something called financial grade API, or FAPI, comes up, and those require the use of sender constrained tokens, which is quite funny because then there was no support for that in OAuth. And suddenly a bunch of banks and financial institutions are required to come up with some sender constrained token things. So what they did, they introduced a new RFC called 8705, the OAuth 2.0 Mutual TLS Client Authentication and Certificate Bound Access Tokens. So in other words, what they did, they took what they already had, because big financial institutions, banks and everything, they have PTIs in place, they have everything they need for mutual TLS. But if you're like me and you worked in a lot smaller companies, SaaS providers and things like that, you know that having the infrastructure needed for mutual TLS, that's quite hard. But luckily last year we finally got something that is easier. So DPoP, demonstrating proof of possession, specified in RFC 9449. The full name of it is demonstrating proof of possession in the application layer. So in other words, we have moved the whole thing up to the application layer. So let's take a quick look at how it works. So the client now has a private and public key pair, and when it requests the token, it creates a DPoP proof. We will look into that afterwards. That is signed with its private key. That DPoP proof that is added as part of the token request, and is sent together with the assertion. So it's the same, almost the same request, but we are added a DPoP proof. We will look at that. The authorization server responds with a token that is bound to the public key of the client, of the DPoP public key of the client. That means that we have a token that's bound to something that only the client has. When the client does this API call, it generates another DPoP proof. This token that's bound to what the client has. And the DPoP proof, which we will look at, says that this is a one-time use DPoP proof for that specific call. So we generate a new call, DPoP proof for everything. We will look into the things behind that. The API server validates both the token and the DPoP proof, so it knows that, okay, you have a valid token, and you can also prove that you were the one the token were issued to. And you get a regular API response. So let's take a look at the token request. So the client sends its token request to the token endpoint, as we can see here, and we have that proof, which looks like this. So the proof is added to the DPoP as a new header, DPoP header. It's a JOT, so when it's decoded, it looks something like this. We have a JSON web key here, which is the public key from the client. We have a unique identifier to prevent replays. We have an HTM, which stands for HTTP method. We say that this is proposed, and we have the HTTP URL. So we're saying that this proof is it's one-time use, it's for this specific endpoint and this specific method. Then, of course, when it's issued out, and then you can say that we only accept proofs that are less than a minute old. That is validated by the authorization server, which returns a token response. That looks like that, and as we can see here, it no longer says bearer, it says DPoP. So in other words, we have a new token type. We don't have a bearer token, we have a DPoP token, which means that the contents of the token probably also changed. And of course it did. And the interesting part here is that we have a confirmation claim. And that confirmation claim contains a JPT, which is a base64 URL encoded SHA-256 thumbprint of the public key of the client that the client sent as part of its DPoP proof. So we can say that the access token is bound to the public key of the client. And when the client then sends a new proof to the API, that can be validated by the API, which we will see. So in other words, we now have an access token that's bound to the client, as long as the client, of course, manages to keep its private key secret. But we are better at that than not leaking access tokens. So let's see how we can use this new token. We do an API call. We generate a new proof, and that proof looks like this. So we still send the token in the authorization header, and as the specifications say, we have to tell what kind of authorization this is, and in this case it's DPoP instead of a bearer token. We also include the DPoP proof, which is in its own header. And the DPoP proof looks like this. As you can see, it's the same. We have an identifier to prevent replays. We have a method. We have the actual endpoint when it's issued. But we also have this that we didn't have towards the token endpoint. And remember how I said that the access token is bound to the public key of the client? Well, the proof is bound to the access token. So the ATH claim, that is a base64 URL encoded hash of the access token, which means that this proof is only valid with that specific access token. So you can't just steal the proof and use it with some other token you have obtained. And as long as we have the GTI, the API is capable of preventing replays. So that's it. And if the proof leaks, since we don't allow replays, as long as this is implemented correctly, the proof you won't be able to reuse it. So that's it. DPoP is actually quite simple. A lot of people should start using it. That's what I'm working on. The health sector is starting to require it in a lot of their APIs. In the future, a lot of more places will do. We are still waiting for the big public facing APIs like Google and things to use it. But of course, there is a risk. You have to, because is it a risk that the tokens might get leaked? Do we want to force our developers to use DPoP? It can be a bit hard. It's harder on the API side because the API suddenly has to implement support for replay, for checking replays. So on the client side, it's actually quite easy. And of course, we get a response back. So yeah, that's it.